Hi, my name is Franco Pestilli from the University of Texas at Austin. I will be talking about interoperability and cloud computing platform. More specifically, I will be talking about brainlife.io. What is brainlife.io? It's a public, open source, and free cloud computing platform that supports reproducible neuroimaging research. Provides integrated data management, pre-processing, and visualization. It connects code wizards with data gurus to the top supercomputers, promotes data sharing, code sharing, and advances scientific discovery. These are the three pillars and the three communities that contribute to the platform: code developers, data generators and archives, and supercomputing and cloud providers. There's three primary data modalities that are currently supported on the platform: anatomical MRI, functional MRI, and diffusion MRI. From these basic three modalities, multiple data derivatives can be generated, brain volume and surface analysis can be applied on the platform. Brain network, both functional and structural, can be created on the platform. And then white matter mapping, both macroscopic and microscopic properties of the white matter can be studied on the platform. So how does it work? If you log in and enter the platform, data organized into projects. Each one of the project is managed by the data manager. They decide access to admins and members. Data can stay private as long as the members of the project decide so. Data can be processed individually, one subject at a time, or it can be processed via pipelines that apply automated processing across all the data and subjects within a project. Data can be also visualized. Here is an example visualization of the visualizer that we developed within the project, but also we use visualization routines and software developed by the community. The BrainLife community has been growing now since its first release about 3 years ago. We have users, over 1,500 user accounts created and about 100 users actively every month. Users are, as you can see in this map, are distributed in different parts of the globe. Interoperability. Data archives, data standards, and software libraries are three key aspects of software and neuroinformatics development out there. And these are the three assets that BrainLife brings together. BrainLife connects archives and software libraries via data standards, so to allow researchers to be able to process data on the cloud. Data archives, we connect with multiple archives. We are in partnership with OpenNeuro, and we can you can move data from OpenNeuro to BrainLife and vice versa from BrainLife to OpenNeuro soon. We also connected with the INDI, International Neuroimaging Data Sharing Initiative, and many more. We indeed use DataLab as a decentralized data management system that allow us to connect with openly shared data sets across different projects. Here is an example. Within the platform, you can go to the dataset tab. Here, all the data sets that are shared through DataLab appear. Here is a data set from OpenNeuro, and you can import automatically this data set, creating a project, selecting the type of data, and creating a new project or importing into an existing project. And this will automatically grab the data and move it into now a project of your use. Once the data is in the project, you can see both the metadata and the neuroimaging data have been moved. You can then process the data, explore the data, visualize the data using different the major software libraries for visualization. So data from archive becomes actionable on the cloud platform and allowing researchers to happen. Software libraries are also the workhorses of the platform. DiPi has been one of the early partner for the project. FreeSurfer, one of the top used libraries on BrainLife, FSL2, MRTrix, Work Connect and Workbench, MRQC, fMRI Prep, DCM2 and NiPipe, VistaSoft from Stanford University, NiBabel, AFNI, and ANS. All these libraries and more are bridged together into different apps. From libraries on BrainLife become services. Here, going back, you can go to the app tab, and here you see where the services are. Service is an app. An app is a ready available processing stream within the cloud ecosystem that you can run on the different resources that are made available by the developers for running analysis. You can read instructions that the developer leave on GitHub. All the apps live on GitHub, and you can also monitor who's using this app. You can see there's different people in green that just successfully completed the app, and some of them are waiting for the app to run. You can run the app from within this interface, or you can also run the app from within a project, as I showed you before, through the process or pipeline tabs. In practice, software libraries come alive as cloud services on the platform. The second axis is data standards. We are compatible with the brain imaging data structure. This is one of the upcoming and dominant standards for sharing neuroimaging data. And BrainLife has mechanism for inputs data. Data from scanner can be, and DICOM, for example, can be uploaded to a secure system, EasyBeads, that is upcoming in the near future. And from EasyBeads, the data through a GUI interface can be automatically transformed into a Beads dataset. Once the Beads dataset is created, the dataset can be pushed into a project on the platform and then analyzed. You can choose an existing project again, or you can choose a new project. At this point, you can do data anonymization if necessary. You can correct any mistakes that the automated guesses of EasyBeads might have made, and you can finalize the transformation from DICOM set and to beads, and from there push into BrainLife. Also, there's mechanisms for taking data out of BrainLife into bead structure. BrainLife's allowed to publish your project. That is a bundle that contains both code or services as well as data. This is one example, one project and one release. And you can see here that if you want to download, you can copy automatically copy that script, and that script can be run locally on your terminal to download the Beads version of these data sets generated on BrainLife. There's some level of lack of coverage of some of the data derivatives on BrainLife because some of the beads, for example, beads for connectivity, are still being developed, and we're looking forward for the community to complete that task. Data standards indeed is used by the platform for data exchange, both in and out of the platform. Data can be inputted and outputted via beads, the bead standard. So interoperability is at the core of the BrainLife technology. BrainLife uses community-driven software libraries, some open source and some not open source. And BrainLife connects with major data archives and repositories and acts like the glue between archives, researchers, and supercomputers. Data standards and software are key to our success and the success of the platform. And here I want to thank our sponsors. BrainLife was funded by INCF through the BRAIN Initiative, and we then received funding by NIH, Microsoft, and we're supported by Pittsburgh Supercomputing Center, the Indiana University Supercomputing Center, and TAC Supercomputing Center. And I'm open to questions. Meanwhile, I want to thank all the project members and the collaborators and the other individuals from the community that have participated in the project by testing, using the platform, reporting errors and bugs, and simply just using it for their research. There's been several papers now that have been coming out with us involved and without using the platform. Thank you very much.